This is the solution video for section 2.2, problem number 10. All right, so it says write an equation in slope-intercept form for the line tangent to the graph of f of x equals x to the sixth plus 2x to the fourth at the point where f prime of x equals 12. Round the y-intercept to the nearest thousandth. All right, so as soon as you see this nearest thousandths, you know it's going to be a calculator question. All right, so it says write the equation in slope-intercept form for the line tangent to the graph of this. All right, so first of all, I need an equation for a line tangent, right? So I'm going to need the derivative. All right, so let's start here. I'm going to write f prime of x equals. All right, so this is a basic just power rule. So I have x to the sixth, so the derivative would be 6x to the fifth plus derivative of 2x to the fourth, so 8x cubed. All right, so now this is the derivative, okay? Now, in order to find the slope of the tangent, right, m tan, I want the derivative evaluated at some number, right? But what number? Well, it says at the point where f prime equals 12. So I need to know when 6x to the fifth plus 8x cubed is equal to 12. Now, this is a calculator question. So let's be smart. Let's use our calculator. All right. So I'm going to bring up my calculator. All right. So I've got my calculator here, and I'm going to graph 6x to the fifth plus 8x cubed. So 6x to the fifth plus 8x cubed. All right. So now I'm going to set that equal to 12, right? So I want to see when those two things are equal. All right. Now, first thing, if I hit graph, I'm going to see that curve, right? That's that 6x to the fifth plus 8x cubed, but I don't see the second curve. Why? Because I'm only going up to 10. So you want to change your window. You want to change the y max to, well, let's say like 15, greater than 12, right? So if I hit graph now I'll see both of those, and that's where they intersect. So I'm going to use second trace. I'm going to use number 5, intersect. All right, so first curve is first curve y1, yes, so hit enter. Second curve is second curve y2, yes, hit enter. All right, now guess. Well, there's only one point of intersection, so I can just hit enter again, but you could always type in like, all right, let's say it's like 1.5. We're guessing that it's near 1.5. All right, so I'm going to hit enter, and it turns out that it is this value, x equals 0.960627, or I'm just going to round to 3 decimal places, 0.961. So x is equal to 0.961. All right, is that the right value? 0.961. All right, and so that's the x value. So I want to know f prime of 0.961. Well, remember, f prime of 0.961, we already know what that is. That's 12, right? That is the slope of the tangent, right? We're given that. So now I need to know the point. The point is going to be at x equals 0.961, comma, f of 0.961. So what does that mean? That means I need to plug 0.961 into the original equation, right? So I'm going to go back to my calculator, and I'm going to, now this x value is stored. So if I go to my regular calculate screen and I just type in x to the sixth plus 2x to the fourth, right? I'm actually using the stored x value from my calculator, and I get that the y value is 2.489. We will round, right? So this is 2.489. And so my equation of the tangent line is going to be y minus 2.489 equals slope of 12 times x minus 0.961. All right, but it does say right in slope intercept form. So that means I need to distribute the 12. So I have 12 times x minus 12 times 0.961. And then I need to add 2.489. So I need to take 12 times 0.961 plus 2.489. So 12. So I'm going to add that 2.489 to 12 times 0.961. All right, and so if I do that, I get 14.021. So y equals 12x. Oh, and that was a minus, so that is incorrect. So that would be, sorry, that should have been minus. So I'm going to take my 2.489 and subtract 12 times 0.961. All right, and so that is negative 9.043. So minus 9.043. 3. And so that is my equation in slope-intercept form.